All right, let's move on and look at our last two examples here in our notes. So we're studying parabolas. Now, as we look at the equation of this parabola, we got 2y squared plus 8y minus 16x plus 40 equals 0. This is a quadratic with our squared term being the y term. So we know graphically we've got a parabola that's going to open right or left, right? Just knowing the squared term is the y term. And what we're going to do before we talk about its graph, right, is we want to rewrite this in standard form. So with our y term being the y squared term, our goal is y minus k squared equal to 4p times x minus h. So let's work on getting in that form. So as we do that, let's go ahead and take our y terms. Let's go ahead and group those together on one side by themselves so we can eventually create the square. And I'll leave a little room. Remind me I'll be adding a new constant, right, to create the square, half of b squared. Now this x term, the constant term, we need to move it over. So we would have to add the 16x over and subtract the 40, right, to move it to the right side. So again, rearranging it to get it in the form that we're looking at. So with that said, again, we've added the 16x on both sides, right? We subtracted the 40 on both sides to move those over. Now, before we can create the square, right now, notice my coefficient of y squared is 2. Well, we want it to be 1. So let's go ahead and make that 1. So what I'm going to do, I'm going to go ahead and divide out on both sides. Let's divide this 2 out. So we'll go ahead and make it a 1. As we do that, now we've got our equation that would read y squared plus 4y equal to 8x minus 20. All right, dividing the 2 out. Now we can create the square, right? Now we've got the coefficient of y squared to be 1. Well, to create the square, we identify b. So b is 4. So we're going to take half of that. So we're going to divide that by 2. So as we divide that by 2, we get 2, right? So we're going to add in a 2 squared on both sides. This equation, to keep it equal, we've got to do the same thing to both sides. So let's go ahead and do that. And now we look at our equation. We've got a y squared plus 4y plus 2 squared. Well, that can rewrite now as a square. That's y plus, half of b. This is y squared plus by plus half of b squared. So that's the same exact thing as saying y plus half of b, y plus 2, all raised to the second power. We square y plus 2, we're going to get y squared plus 4y plus 4 back. And on the right-hand side, let's go ahead and simplify. We got 8x minus 20 plus, again, this is 4. So that's a negative 16, right? So I'm going to take this a little bit further. We know that with the right side, we got a coefficient of 8. We want that coefficient to be 1, right? What's the coefficient of x need to be? A 1, not an 8. So we need to factor that out. And while we have it, if you want, let's go ahead and rewrite y plus 2 with a minus sign just to see it in standard form. Again, whatever's subtracted from y gives you the y coordinate of the vertex. That's a negative 2 being subtracted. And over here, as we go ahead and factor the 8 out, we got x minus what? 2. Right? 8 times x. Again, you got to factor that 8 out of both terms. So it'll be a 8x minus 16. We would distribute it back through, so we factor the 8 out of both. But now I've got exactly what I want. There's the value of 4p, and there's the value of h. So as we're talking about our graph, right, we know our vertex, right, would be, again, the ordered pair h, k. Well, h is 2, and k is negative 2. So 2, negative 2. And now to get our focus, right, and our directrix, we're going to need the value of p. So what does p equal? So we know, again, that 4p, right, 4p is equal to 8. So as we're solving for p holds a value of 2. So if p is 2, so remember in our parabola, we knew we open right or left, so we know at this point it's going to be a parabola that opens to the right. So let's go ahead and draw it in. Let's go ahead and build our x and y axis to get a quick picture of what we found. So 2, negative 2, right 2, down 2. So down here in quad 4, here's our vertex. So go ahead and plot that ordered pair, 2, -2. And our focus, let's go ahead and measure out 2 units. So as we measure out 2 units, right, to the right, there's our value of P. P is 2. We get this ordered pair, we add 2, right, to the x-coordinate. We'll be sitting over here at the point 4, -2. So 4, -2, right, is our focus. So let's go ahead and draw that in a little bit better. So again, that's 0.4, -2. Now in our parabola, again, we knew it opened to the right, right? It focuses in on that ordered pair. So there's a sketch of my parabola. Now let's go ahead and do the directrix, which we haven't labeled. Now we went right 2 units. Well, we're going to go left 2 units, right, to get to the directrix. So left 2 with a point 2, -2, right, forms our directrix, which is right here at the y-axis. So x equals 0 will be the directrix. So again, I've subtracted 2 from the x-coordinate, right? 2 minus 2 gets me to x equals 0. So our focus is the point 4, -2, and our directrix is the vertical line x equal to 0. But again, the key, right, was getting that standard form. Once we had the standard form, we got everything we need right in front of us. We have h and k, the coordinates to the vertex, right, looking at it in front of us. And we had the value of p, right, because we know 4p is the coefficient of the first degree term. So we can solve for p, and then we can plot our focus and directrix. That's the distance traveled from the vertex, right, the equal distance from any point of the parabola to the focus and direction. So again, that's a good example. Like that one, again, because it's not in the standard form, we had to do a little work to get it. So creating a square really was our work. Now let's take another example. Do one more. It says here in our next example, for the parabola 3x squared minus 36x plus 12y equals 0, find the vertex, the focus, and the directrix, and draw in the graph. All right, so with this example, well, I know right off the bat that we're looking at a parabola that opens up or down, right, because we're dealing with the x squared term. So let's go ahead and talk about our goal, our standard form for this equation. So we want to create a square with the x terms, x minus h squared equal 4p times y minus k. So let's go ahead and work on that. So what I'm going to do is, again, to create the square with x, I've got to get the x terms together by themselves on one side of the equation. And we need to go ahead and move the y term over to the right side. So I'm going to go ahead and subtract 12y. And left a little room beside x. I'm going to have to introduce a new constant, right, half of b squared, in order to create the square. Now, one thing you will notice, our coefficient of x squared is not 1. So if it's not 1, before you create your square, make it a 1. So we can divide out of 3, we can make it a 1. So let's go ahead and do that. So now our equation reads x squared minus 12x, right? 36 divided by 3 is 12, equal to negative 4y. And now we like it. Now we're ready to go. The coefficient of x squared 1, so there's our value of b. So b holds a value of what? Negative 12. Right? So let's go ahead and take half of that number. So b is negative 12. We got to divide that by 2, right? And we're looking at the value of negative 6. So we're going to add in a negative 6 squared on both sides of our equation. So to create a square is half of b squared. All right, so as we do that, now we can write the square for this new quadratic trinomial that we've created. So let's go ahead and do that in the next step. So we got x plus half of b, x plus negative 6, that's half of b. Right, all of that raised to the second power is the same thing as x squared minus 12x plus negative 6 squared, which is 36. Yeah, if you were to square x plus negative 6, you're going to get that back. So again, you can see your square being created. You can start to see your x-coordinate for your vertex. Now let's go ahead and simplify over here on the right side. I got negative 4y plus 36. Now with that said, the right side is not quite like we want it. We want a coefficient of 1 here instead of negative 4 with the y term. So let's go ahead and factor that out. Now x plus -6, same thing as saying x minus 6. As we factor the -4 out from both terms, we're left with y minus 9, right? And now I like it. Now I got exactly what I'm looking for. There's h, there's the value of 4p. Well, there's subtracting from y gives you value k. So our vertex, right, for this parabola, that ordered pair h and k, we got an x-coordinate of 6 and a y-coordinate of 9. And then our focus and our directrix, we need the value of p. What does p equal? So we know 4p, right? 4p equals -4, right? Coefficient of the y term. So as we divide the 4 out, p equals -1. So with that said, we knew at the beginning our parabola opened up or down. So we now know the graph of this parabola opens down. P is a negative value. Now as we plot that point, what's right 6 up now up here in quad 1? There's the ordered pair 6, 9. And our focus, as we measure down 1 unit, right here would be the point 6, 8. There's the focal point, right? Our p value again being -1. So we're graphing in a sketch. This parabola, there's a quick sketch of it, looking at the parabola there. So again, our focus, and we write that over here, is that ordered pair 6, 8. Down 1 unit. Now to get the directrix, we go up 1 unit. So we'll go up here to 10. We can plot the point 6, 10 if you want. And we draw the horizontal line that passes through it. So remember, it's always perpendicular to the line of symmetry. So it'll be y equal to 10. So again, the value of p was again 1 unit. So we had a -1, right? Up 1, down 1. So our directrix is that horizontal line, y equal 10. So there's your sketch. So again, we've given a quadratic, not in standard form. Once we got it in standard form, we got everything we need in front of us. Got our information. So again, there's our graph of this quadratic.